right, so segment constructions. If we look at the first section, the directions are to construct a line segment congruent to each given line segment. So what we would normally do in this situation is we would measure this with a ruler and we'd make a new line. Before rulers were invented, they had another method, and we often use it if we're doing a drafting kind of thing or geometry constructions because it still works and you don't have to measure anything. Okay, so see this line segment's kind of going this way? We're actually going to copy it onto a horizontal line. So I'm going to just take my pencil and draw a horizontal line down here. I haven't measured it. I'm just making sure it looks longer than the one that I need to make. Okay? So I just need something longer. It needs to be straight, using a straight edge. It needs to be longer than the one I'm going to copy. Okay? So I'm going to make an end point for my segment right here on the end of this line that I drew. And then I'm going to use my compass to measure. Okay, so if I take my compass, I'm going to put the pointy end on the left side and the pencil end on the right. And to make sure that this is lined up, I'm just going to take a quick swipe to make sure it goes through the end of that segment. So what I just did is I used the compass to figure out how long the segment is, and then I'm going to copy that distance down here. So I can take my compass down here, the little pivot, I call it a pivot right here, and just swipe your pencil through, and we can put another little end point right there, and this segment right here is congruent to that one. So when we talk about them being congruent, they're both segments and they have the same length, so we can say that they are congruent. All right? Does that make sense? Mm-hmm. We're going to do the same thing on number 2, and you can draw the line segment any direction you want. Just for fun, let's make this one go vertical. So just as long as you're drawing a line to start with that's longer than the one that you need, you can draw it any direction that you want. So I'm going to put my end point on the bottom this time, and then I'm going to use my compass and measure from this end to this end, so you adjust so that they line up. And then I'm going to come down here and just swipe. Oh, it's all, yeah, I don't know if I talked about this, but you want to swipe it through the end of this one just to make sure it's really lined up, especially if you have thick pencil lead. And then come down here and swipe. I was a little bit off the first time, so I'm going to fix that. And then you go ahead and put the point in there, and then this segment is congruent to that one. You don't have to draw the arrow. I'm just sort of using that to explain. So that's how you can draw congruent segments. And this concept is really useful if you're going to use the same measurement over and over and over and over again in a picture. You just take this and you measure it out, and you can do all kinds of cool things just knowing how to copy a length. Okay, so let's go down here. It says construct a line segment whose length is equal to the sum of the lengths of the given segment. So they want us to add these two together. Same concept, except we're going to have to do it twice. So for number 3, I'm going to draw my line this way, and it needs to be long enough that I can put this top segment and the bottom segment on there. So I just made it extra long down there. And I'm going to put an end point on this side just to show where I'm going to start. So you can take your compass and come up here and measure the top line first. It's not that much different than that last segment we did. And I'm going to copy that distance down here, like that. Okay, so take a moment to copy the first distance. And then what do you think we're going to do to add on the second distance? Yeah.
So measure that one with the compass and then add it on to the other.
Okay, so we're just going to measure this one with the compass. So I'm going to swipe just to make sure it's going through the end. And then I'm going to add that over here. And that's where I'm going to put my other endpoint. So it'll go right here. We'll put the other endpoint right there. And so these two are the sum, or this whole segment right here from this endpoint to this endpoint is the sum of those two segments. All right, so let's do that again on number 4. And I think the horizontal lines are just easiest, so I'm just going to go ahead and do that again. You could make it vertical and take it up the side of your paper if you wanted to. just for fun. So, and I'm going to make my end point just to show where this segment's going to start. I'll come up and measure the top one, like that. And I'll copy this down. It is simple, and people have been doing this for thousands of years. All right, so do this, and then we come over to the next segment and do this, and bring it down, and just measure that out from the end. And so there's my end point. I just put both segments on there. This and this is the sum of these. So before rulers were invented, before standard measurements were invented, people were using this concept. They were taking a couple of sticks and literally using them to measure. They also sometimes took rope and put a knot in it for a measurement and then took that piece of rope and used it over and over. People still do these things because sometimes you don't necessarily need to know, well, it's 5 feet and 3 inches and 3/4. They just need to be able to copy a distance over. Okay, so let's go down to number 5. It says construct a line segment the given number of times longer than the given segment. So they give us this segment on number 5 and they say they want us to make it 3 times as long. Well, we're just going to use the same idea, except we're going to do the same segment 3 times. Okay, so let's give ourselves some room to do that. So I just used my straight edge. I'm going to put a little end point to show where I'm going to start this process. And this is a tiny, tiny little segment.
It's half an inch.
Okay? But we're not actually measuring it. It might be half an inch. I don't know. It looks pretty close. So I'm just going to take that and swipe to make sure that I'm at the end. I'm going to copy that distance down here. And then it should be, if your compass stays where it should be, you should just be able to, mine's wobbling. You should be able just to copy that measurement 3 times. I was trying to use one of the kind that you guys had.
Maybe it's half an inch then.
Okay, so there it is. There it is. There it is. And so this one has 1, 2, 3 lengths, and so I'm going to put my end point there. So if it does say 3 times as long, make sure you have 1, 2, 3 of them. So this segment from this end point to this end point is 3 times as long as that one. Okay? And then we're going to do one that is 5 times as long. So I'm just going to make a little line down here that I could extend or do whatever with. And I'm going to make my endpoint to show where my segment's going to start and come. And this looks very similar to the segment we just had. So we're going to use our compass to kind of measure that length. And then we're going to copy it. So how many do we want? We want 5 of these. So 1, there's 1 distance. 2, 3, 4, 5. And you might look at it just to make sure your compass didn't move. Sometimes if you've got the little plastic compasses, they do move quite a bit. Make sure this looks like you copied it 5 times. Okay? So those are all based off of the idea of copying a segment. So we copied a segment, we constructed a segment that was the sum of 2 lengths, then we constructed a segment that was a given number of times longer. Now we're going to switch gears and learn how to do a bisector. So we talked about segment bisector in our vocabulary. This is going to take that a little bit further. It says we're going to construct the perpendicular bisector of each. So bisector means we're going to cut it in half. Perpendicular means that it is going to make right angles when we do it. And we probably should have given ourselves a little bit more room on the paper, but we're going to do the best that we can. So we're going to try this. If it doesn't work, we'll peel the bottom off and glue it onto the other paper, and then we'll try again. So this one, you don't copy anything. We're going to do something quite different. So you locate where the endpoints are of your segment. Okay? And then we are going to take our compass, we're going to put this on one end, and we want our pencil to be somewhere more than halfway. So I'm going to choose about right there. It has to be more than halfway between this endpoint and this endpoint, or it won't work. So you guys understand what I mean by about halfway. So you're going to estimate about where halfway is. You're going to go a little further. Okay? And so above, I'm going to mark that distance like this. And then I'm going to come to the other side and use the exact same distance, and it's going to make an X. And then if we have enough paper, which is starting to look a little doubtful, you use the same measurements and go below. I think mine's just barely going to fit. And if we run off the paper, maybe the next one will work because it's kind of, oh, it's like right to the edge of my paper. So it's supposed to make an X above and below. You can adjust it in. It can be barely more than half, so I could take this one in a little bit. As long as it's more than halfway, as long as they cross to make an X, it's good. So I took mine in a little bit, and it made an X. And basically, if I connect where this X crosses to where this X crosses, it should go right through the middle of my segment. So we're going to take these.
Wait, how do you make the X's?
So
By crossing the two.
So you take your compass like this, and you've got it measured more than halfway. Red, are you listening? Measured more than halfway. So on the bottom, you can pull it in a little bit if you're going off the paper, as long as they're still going to cross. So you take the same distance from the left and from the right, and you want it to make an X. As long as it's more than halfway, it doesn't have to be much more. And so this point right here, it should look like it's dividing this segment in half. This piece should look the same as this piece. If it doesn't look the same, then you didn't do it right. So when it talks about perpendicular bisector, this should also look like a right angle. If it doesn't look like a right angle, then something went wrong. It should look like a right angle, and it should look like it's dividing this segment in half. Okay? So, yes.
Can you draw circles?
You could draw semicircles from the top to the bottom, but I knew that this one down here was probably, I was going to have to pull it in a little bit, so I didn't do that. We can try that with the next one if you want. So what Jaden's asking, you just need to make sure your pencil's more than halfway, but it doesn't have to be a lot more than halfway. And if you want a number 8, since it's kind of tilted, you can turn your paper. Like, that is the easiest thing to do. If it confuses you and something's crooked, just turn the paper. And just make sure you're a little bit more than halfway. If you're halfway or less, they won't actually make X's, and you won't get accurate measurements. So see how I'm just a little bit more than halfway. I'm making a mark above. Here, I didn't go far enough. Hang on. So what Jaden was asking is, could we just take this and sweep it all the way through the bottom and do the same measurement this way? And my pencil just broke. Let's see if I can make it work just a little longer, like that.
Yeah.
And you can. If you just want to do two like semicircles, they're not quite semicircles, and sweep it through top and bottom, that also works. You don't necessarily have to have all of this in between. And then you just take these 2 points where they cross with your straight edge. I'm using the edge of my protractor, and connect them. And we should be looking for 2 things. One, does it look like it's perpendicular? Does it look like this is a right angle? And it does. And then it should also look like this piece is equal to this piece. They should be congruent, which is that word we talked about in the beginning. These 2 segments should look the same.
Did you get a worksheet?